All right, so today I'm hoping to get to at least the very end of the OOP review. And so next Tuesday, we can start you fresh with a new topic for this course, exceptions. And I will make some announcement quickly, and then there will be some important information for you to consider, which I believe is good for you. Okay, your Lab 0 Part 2 will be due tomorrow, Friday, the same time, 12 noon. And make sure you submit in time to claim your credits. And your Lab number 1 will be released maybe shortly, either before or after. I'll make it available for sure tomorrow. So if you want to start over the weekend, work on that. And then next Wednesday will be the best chance to really get all your doubts clarified, so you can just get ahead with the Lab number 1. And just want to let you know, if you didn't come to the scheduled lab session yesterday, I illustrated the programming pattern that we have to use for both all of your labs and also your programming tests. How can you find them? You can just go to the study site. You can see it's here. I made both recordings, the notes, and everything's there, and the source code. And it will be up to you to play with it and make sure you really understand the pattern. In the written test or programming test, it's all possible to ask you a question about it. Quite many questions can be asked from there. So please, for your benefits, you want to study that. And as I mentioned briefly, I'm going to make an announcement. Sorry, I forgot. I'll do that right after the class. So today, I cannot really make it to the office hour at 3 p.m., but I'm going to reschedule that. Maybe not this week, maybe to next week, because next week you're going to be maybe more struggling with lab number 1. So it might be wiser, for your advantage to have extra office hour next week. And this is important, all right? Which is something I said I kind of promised I would do for you. Let me tell you what this is about. If you look at the semester calendar, give me a moment. If you look at the semester calendar over here, so we are now here. Sorry, beg your pardon. We are now 19th. Your very first programming test is scheduled to be about more than 2 weeks away. However, I think since it's your very first programming test, it would be very beneficial if you can maybe sit down in the actual lab and take a practice test before I release the practice test to you. That could be a nice practice chance. Optional, but I think it would be nice to offer this opportunity to you. Offering that next Wednesday is not a good idea because you're going to be struggling with your lab number 1, so I'll rather reserve that time for Q&A and also do some demo if necessary. So maybe not next Wednesday. And if I choose this week over here, it might be a little bit too close to your programming test 1. You really want to get a feel about what your weakness might be by taking a mock-up test. So I kind of talked to our tech team. The best time that's available to us will be Friday, 27th, next week. Okay? I'm going to make an official announcement later today or tomorrow. You can mark on your calendar. It's going to be next Friday, September 27th. And then it's going to be 2 sessions, either 5 p.m. to 6 p.m. or 6 p.m. to 7 p.m. You can choose the time you will prefer. Right? And then before then, I will also release the programming test guide for you to go through to know what the programming requirements are. So what should you really get prepared for that? Ideally, you want to make sure you really understood everything that's specified, that's really reviewed in the, in the first 2 weeks, in the Lab 0 and also in the lecture. And then if you can get done as much as possible for lab number 1, that will be your best preparation. So this practice test, we'll try to also grade it as well, so we can also give you some feedback. Right? So that's the idea. So we should really hold this test early enough so that you can still get some time to make up for whatever your week. Right? That's the best I can do for you. 5 p.m. or 6 p.m., I will be there. And if you can make it, feel free to come. If you cannot, that's okay. I'm going to release the practice test anyway. You will just have to simulate that environment yourself, maybe in a lab space. Completely up to you. Okay? All right. Let's take a quick look of what we did last time. We did just a few items last time, but I thought it was very, very thorough. So I think it's important for you to know what we really have done. So we continue with our example about the primitive array. We learned about how to trace the loop. That's important for you to know. And we went on to this particular example over here about how you can trace object creations and also copying address in the context of array. Right? We did the whole session basically last time discussing just this example. In the middle, we also talk about if you got two arrays over here, what does it really mean when you have a variable assignments? That could be useful for you as well. So make sure you review that part for clarification. And we talk about basically, just follow-up discussion about how that example. You should just go back to the lecture if you got any doubts, or reach out to me. And we also talk about aliasing path. Whenever you have aliasing happening in your runtime, basically once you have drawn the diagram, look at the object itself and see how many incoming errors there are. And that will tell you how many variables or expressions are storing the same address. That's aliasing. And we talk about how the reference type return value can work. In fact, from yesterday, for the in-lab demo, we even talk about if the return type is actually point array. That's also possible, right? Point array or point, they're both reference types. They're all possible to be the return value, right? That's something you would like to study as well and clarify. All right, that's about it. And yesterday, the in-lab demo we did, we basically walked through some runtime structure like this. So this should also be something you should feel comfortable of drawing and tracing for all your labs and programming tests, or even written tests. All right, before I move on to more review, any question about what we have discussed so far? Any part you want me to repeat or clarify? Feel free. I'm okay to be slowed down. Yes, go ahead. Yeah, so the question is for product app.java, right? I would say since the instructions say you should really just follow what I type, right, in the video, I think you should really go faithfully with that file, yes. But starting from lab number 1, you will not have to type with me anymore. That's a good thing. So just do for part 1 and part 2, all right? All right, any more questions? If no, let's now move on to other topics, all right? Let me go back to the slides. And we should really start with, so slide 53 is where we went up to last time, this example here that we traced in detail last time. And slide 54 is basically about what I illustrated yesterday, right? If you went through the in-lab demo, or you can just go through the slides, I'll leave the choice to you. So that's really also corresponding to the required reading that you were given since day 1. You have to make sure you really understand that document, right? Cannot emphasize enough. All right, so these 2 slides are already covered. And let's now move on to some light topic, but I think it's very practical. It's something about anonymous objects. Anonymous simply means objects without any names. You can refer to certain objects in the memory without having some variable storing their addresses. That's the idea. It's why it's called anonymous. The analogy I would like to make, if that helps, if you just take a look at these 2 methods over here, number 1 and number 2 on the right, they are not really involving any objects over here, just expressions, right? Take a look at them. What I want to point out is, let me just tell you the insight you want to look at. So for now, just look at these 2, right? On the left-hand side, we want to return some double. So what we do is we store the result that we want to return into some intermediate variable. So this expression here has a name, which we call SQR. And then we return that, all right? So you can think about just this expression alone is anonymous. But once we do the variable assignments, we can use a name of some variable to reference it, okay? So let's see. Here, you can see on the right-hand side, we just return directly this expression here without having some intermediate variable like SQR, right? That's maybe something you have already been doing, but maybe you haven't thought about it. Anonymous object go with a similar thought. So let's say this. On the left-hand side here, we want to return some person objects, let's say, for the method. What we can do, let's say we don't want to do any objects without any name. So we can say create a P, right? New person, and then just return P, right? So this expression alone is anonymous. However, if you try to assign this to P, now we can use P as the name. Okay? And then here on the right-hand side, we can now just return directly the object expression. So this over here is something we call object expression. Without referencing a variable. Right? So this is just one application of using anonymous objects. All right? And let's now take a look at different examples so you will get a feel. But the best way to learn about this is to start applying. I would say for many lines in your Lab 0, Part 1, and Part 2 already, you can feel free to look at those lines rather than storing the object expression like a new into the variable. Can you convert it into some anonymous object expressions? That will be some exercise for you. That will be the best way to practice. Now let's take a look at this. Let's say we have a class called member. All right? And the member has certain orders, array, and also number of orders. That's the pattern, right, that we have been talking about. Let's say we have two methods over here. We have method number 1, which is called add order. We have method number 2, also it is called add order. Now we're having two methods with the same name, but their parameters are different. You can see the first parameter here takes an order object, which can be distinguished from the second add order method with the same name, but their parameter is different: string, double, and double. How do we call this kind of phenomenon when you have method with the same name but different parameters? Overloading. Thank you. That's something we mentioned also in the slides, right? Overloading. And once we introduce another term later in inheritance, that term can be easily confused. But for now, just understand overloading. Okay, overloading. If you compare the parameter list over here and also the parameter list over here, whereas the name of the method is just the same, overloading, right? That's a side note. Let's say now, we have already defined this method here. How do we add an order? Very standard way to do it. Update the array, update the counter, right? That's a pattern. Now, how can we use anonymous object for this one here, for this one? How do we do that? Basically, this one here just provide the user of your method a different way to add an order. Rather than passing an order object over here, we allow them just to pass the information that will be enough for us to create an order object internally in the method. Right? That's kind of the idea. Let me just give you different versions. You can see some progression about what we can do. Let me give you hopefully this easiest to understand version. And then we'll go from there to anonymous objects. Why don't we say, based on this information, we're going to have some local variable order. So we can say here, order, and then we can say O will be new order. And how do we create an object? We can use the three pieces of information here, N, P, and Q. And one thing to note, the three parameters over here, right, they are being used as arguments to call another constructor. Right? You can see parameters are being used as arguments. Right? That's another application of the terminology that we said before. Right? Again, these are the three parameters, but now they are being used as three arguments to call another method, in this case, constructor. Right? That should be clear. Let's create this object here already, and what should we do? We do exactly what we can do over here. Right? So here you got two choices already. Let me show you the one without using helper method. Right? Remember helper method, we can use it. We can do, first of all, we can say this dot orders array at index number of orders is assigned to the O that we just created. And then you want to update the counter ++. So here, I'm not using this. That's OK, because there's no shadowing that's going to block the access for the name. There's no clash. All right, so that's version number 1. You can think about version number 1. But I can give you version 1.2 by using helper method. You can see that this block of code is a repetition of this block of code. Agree? Repetition. How can we get rid of this smell from the code? We should call on helper method, right? Yeah, agree. Okay, I just want you to really know the logic over here. So now, rather than repeating these 2 lines, why don't we just call this existing method here as a helper method? So what you can do instead is to say this dot add order over here, and then just use the O. So we already see 2 versions over here. Version 1.1, line 1, line 2, line 3. Version 1.2, line 1, and then line 2. Both of them work. But I got to experiment with them just to make sure both of them actually will pass the test cases. All right, so let's now do the final version. Now that we know we can use the helper method, is it possible not to even have this intermediate variable? Just use the anonymous object directly. Indeed, it is possible. So version number 2, I'll put here, is to say this dot add order. So I'm calling this version of the method here, this overloaded version. And then over here, I'm just going to copy this expression here, new order MPQ. And I'm just going to put it here. I'm running out of space, but if you look at the slide, that's exactly what's being shown. I can put it there. It's valid. So I don't have that intermediate local variable O. Right? So we see 3 versions over here to implement this method. Which one is better? I would say this method is so small, it doesn't really matter which one you use, but you have to know how to interpret each version there. Right? One is repeating without using any helper method, without using any anonymous objects, but we gradually get to a single line implementation by using helper method and anonymous objects. That's the conclusion on this, right? Any question about here? All right, so later on, if you read somebody else's Java code, don't be too surprised if they don't create so many intermediate local variables. They just have a very long line of expressions. It's not uncommon. Okay. Let's go back to the slides, and these are the examples we talked about. And this is just this is just the one we just talked about. And this is just another one, right? Just calling the overloaded method here, and we're just passing the anonymous object here, right? That's it. That's it about anonymous objects. Any question? Any part that's confusing to you? Yes, go ahead.
Is it better to go with anonymous objects?
Yeah, it's a very good question. The question was, is it better practice to use anonymous objects? It really depends. Really depends. I would say you don't want to go extremes. You don't want to say, I don't use any I can sketch some very general principle. Of course, you have to really judge to see in your code. So you can either go for one extreme to say, no anonymous objects. Oh, yes, thank you so much. I might do that sometime. Please, just shout out to me. If you have no anonymous objects, in this case, the consequence of that, you just have many intermediate, many local variables. Let's go for the other extreme. Let's say there is no intermediate variables. That means you want to use anonymous object as much as you can. The result will be a very long expression to read. So you can see these two are basically the drawback for either extreme. Either you got so many intermediate variables, maybe some variables are only being used once just for referencing the anonymous objects. Or you just have some very, very long expression with new keyword throughout, right? You really have to see which one is better, right? So I would say choose somewhere in between. You have to really introduce somewhere in between is better. Sometimes you really have to introduce some local variable for the readability of your code. If you can, you want to do it. And if you're worried about, if I create more intermediate variables, does that mean I'm going to occupy more space? Strictly speaking, yes. If you have more variables, you got more space. But space is not your concern. Don't worry. There's no way you can introduce so many variables, you got out of memory problem. No way. Don't worry. Okay. Alrighty. That was a good question, which does require some experience and trial and errors. Okay. I think we have done some warm-up for today. I think now I just need your full attention. This will be the most tricky example for today. Before that, I'll take a question.
Slide 56.
56, yeah? Give me a moment. What about it?
Where it says the left-hand side can be reused, SQR.
Are you talking about this one here or this one? This one here, right?
No, the upper one.
Upper one.
Yes, it says after L2, the result of X times X. Yes.
It can be reused. Yeah, exactly, because you're saying X times X can be reused by referencing SQR.
Do we mean in the scope of the function? Because after the function is called.
That's exactly right. So here you can see because SQR is actually a local variable. In that case, you can only refer to SQR within this method. That also makes sense because SQR is storing some expression which involve X. X itself is also within the scope of this method only. So, yeah. But of course, if you really want to store some expression that's going to involve attributes, that could be another story. But that's something you can also play with. All right? Any more questions before we do this interesting exercise? All right, let's play a little bit more with the keyword this. Okay. I want you guys to stare at this code fragment over here, and then I'm going to ask you some question. Can you just take a look? This fragment. We have a class, and we have certain attributes, and we have a constructor. Just take a look to know what's going on there. All right, as you can see, we have a class called person, and we have name, straightforward, and we have another attribute here, spouse, which apparently is a reference type attributes. And you can see that when we first create a person, for example, when the person was first born, let's say, and you can see we do not explicitly initialize the spouse. So what would be its value? Null, which kind of makes sense because a person wouldn't be born as married, right? They should be born single, right? Which makes sense. All right, so now we have some basic understanding of this setup here for the template. Now we want to consider one mutator method, okay? Let's say we want to implement a mutator method called Mary. Right? When we call this method here, we might say Jim.Mary Elsa. Again, hopefully there's no Jim and Elsa here. That could be a little bit embarrassing. No, right? No, we're fine. Okay, Jim and Elsa are our victims today. Good. So let's say we want to implement this method here, Mary, and the only parameter for this Mary method here is going to be a person object. So we want to, if you say Jim.Mary Elsa, it's going to somehow set the spouse of someone to someone else. That's what it's going to do. All right? More precisely, here. So we have person template here. We got name, we got spouse. You can see spouse is a person type here. And we got constructor here. Spouse will be null by default. And we want to implement this Mary method. All right? I would say this method turns out to be not so complicated. It would just involve the use of this keyword, which I'm going to explain to you. But I would say one principle I can show to you is sometimes you know you have to implement this method, but you just have no idea what to write inside the method. It could be quite abstract to think about, because once you, whatever lines you write over here, you should work for all the context objects and all the arguments that's going to be passed as parameter. It's a very general way of doing that. So a tip I will give to you is very useful. Always think about what can be some use cases, what can be some example of calling this method here. And for that particular example, what's going to be the consequence in the runtime? And try to reverse engineer to what you should really write over here. So do something concrete on the paper and then generalize it into the method. Do the reverse way, rather than saying do something abstract, general, right away. All right, so before I show you the code, which I think I will talk about it, but now let's consider this. Let's say this will be one use case for the marry method. So we got Jim, we got Elsa, all right? So let's visualize it, right? We know that pretty well. So let's say Jim is pointing to a person object, right? And every person has two attributes according to the template. I'm just going to put name and spouse. And let me just copy that. I will need that for the second object later. And the name would just be a string objects, or just lowercase, doesn't matter. And then the spouse in the beginning should be null. Right? And what about the second person? Elsa. Oh, sorry. The second person will be Elsa. Here. Sorry, I lost my pencil. Just give me a moment. I'll just make sure it's reconnected. There we go. So we got the second person over here, Elsa, which is going to point to another person object here. And let's make it green over here. And the name will be Elsa. And the spouse will be null. Let's assume legal marriage only. Meaning that when you try to marry somebody, you better be single, the other person better be single as well. Let's say. For now, let's make that assumption. But for the method itself, you may have to do some error handling, which we'll talk about. Can we just think about diagrammatically? What's going to be the consequence when we say Jim marry Elsa? What should happen in the diagram? Yeah, go ahead. You want to? Just on the diagram. Don't give me any Java code. I got here Jim and Elsa. What if I say Jim marry Elsa? What should happen in the diagram? Jim will have a spouse. How should I update the diagram though? Should I just put Elsa here? You will point to the object, right? Maybe that's what you're thinking. Okay. So action number one. Jim, the spouse, rather than pointing to null, is going to point to Elsa. I'll draw a little bit better. Let's say here. Let me call this number one. All right? So this one corresponds to Jim dot spouse is assigned to Elsa. Agree? And this marriage should be bidirectional, right? Elsa, the spouse, should also be set to Jim. The second one here is going to be Elsa dot spouse is assigned to Jim. And which should correspond to Elsa, the spouse, rather than pointing to null, is now going to point to Jim. Oh, let me draw better. Right, bidirectional, right? This is what it is supposed to happen in the runtime, okay? And in order to generalize this example here into the method, we ought to know what in the method you just cannot refer to Jim and Elsa because they are not in the scope. You cannot do that, even though you're on the right track. What you should know is, if in this particular case, how can we find what's other and what's this, basically? Let's start with a simple one. Given that we are considering this method called Jim.Mary Elsa, who is corresponding to other over here? Jim or Elsa? Elsa, right? Argument, right? That's pretty good. If you can see that, that's very good. So we should really see that this Elsa over here is really corresponding to other. And we are as if other is replacing by Elsa, right? That's something you will see on the slide as well. And who's this? Jim, right? Context objects. All right, so Jim over here is really this. All right, so what we're doing now is we are trying to somehow generalize these two lines, which work only on this example, into some general block of code that's going to work in terms of this and other. So that's going to make sure it can work on all the potential marriages, right? Now, what should we write? How about the first step over here? Rather than Jim.spouse equals Elsa, we should say this.spouse equals other, right? Equals other. All right, this will be number one. You can see the correspondence. And what about number two over here? Elsa.spouse equals Jim. Other.spouse equals this, right? That's what you meant, yeah. It's private, but now since we are now in the context of the same class in the method, we can refer to private attribute. That's okay in the same class. Yeah. So now we can say in the second step over here, we can say other dot spouse equals this. I think this particular line might be the most confusing to you. We're using this on the right-hand side, right? The way we figure out these two lines of code for this method here is by first considering this example, right? We understand this diagram pretty well. That's pretty straightforward to understand. And then we go backwards to think about, in this case, because we're calling Jim.Mary Elsa, so Jim should be the context object no matter what, right? Just this. And Elsa here should correspond to the other, the parameter. So that's why we just do the replacement. Jim by this, Elsa by other, Elsa by other, right? Now, you can do the reverse thing again to convince yourself. If I have this particular definition for my method, now, why does it work? Well, let's say, for this particular method call over here, because I know Jim is this, replace this by Jim. Also, other is Elsa, so replace other here by Elsa. And now, if you try to trace this particular two lines of code, it makes sense on this example. It will also work for other examples as well, right? It's really like a back and forth process. You want to convince yourself when you're designing the implementation of your method. Are we good for this? Yeah, you will actually, I would say this kind of a use of this is more advanced, that's for sure, than just say this attribute name. This is something I would like you to learn. Question? Yes, go ahead. So other.spouse is okay because if you think about, okay, other here is of type. Okay, the question was, spouse over here was declared as private attributes. So why can we call spouse on this one here, right? That's your question. Okay, the answer is because the person here, the type of other, is corresponding to the context class, the residing class, or the enclosing class right now. So now within this class, we can call any attribute that's private on the context objects here. So that's fine. Yeah, if there's a different class, for example, let's say if you say point. Let's say point. Let's say P1, let's say. In that way, you cannot say P1.x, assuming that x is private. You cannot do that. It's a different class compared with the residing class, right? Yeah. Okay, the question was, The question was, if I write this the spouse equals other than name, if I heard you correctly. Let's say this line first, okay? Guys, any feedback for your classmate? What if I gave you this line in the test? What would be your reaction? Is it gonna work? If I say, rather than this the spouse equals other, I say this the spouse equals other than name. What's gonna happen? Is it gonna do something similar by redirecting the arrow, or is it gonna do something else?
It's going to do something else because spouse is defined as person type.
It's gonna do something else? Yeah, that's true, but when you say something else, that means it still execute, right?
Oh, no.
No, it wouldn't execute. So the answer is, this is not gonna compile even. All right, I'm glad you asked. Let's see why. First of all, this is not going to compile, right? You gotta get a compilation error because this, the spouse, according to the definition, spouse is of type person. On the other hand, other than name is of type string. How can you assign a string to a person, right? You cannot. So compilation error. It's not going to even do anything. You cannot even execute the code, actually, right? Good question. I love it. Good question. All right. That's good, except we want to do one more thing. I think currently this method is not exactly robust. That's a word you also hear people saying, robust. Robust means it can work only on certain input, but wouldn't work on others, right? So here, I think we are having some very fortunate case. You can see Jin, before he got married, he was single. And Elsa, before she got married, she's single. But what if one of them was not single and they hid the truth? That's illegal, right? We should really stop that by even allowing the marriage. That's something we would like to write into this method here. So that suggests we might need some kind of if conditional to say, if the marriage that we are proposing is illegal, don't do anything or signal some error. Otherwise, allow the marriage to happen, something like that. Okay? Let me give you that structure, and I would like you to work out that condition for me. So what I want to say over here is, let me put it here. I want to say, if some condition over here, all right, I put a star, which means we're going to put it here, right? I'll need your input. If some condition happen, we are actually going to signal some error. And when I say error over here, we have to wait until we learn about exception. That'll be the proper way to do it, which we're going to do next week. But for now, if you want to do it, you can just say system the other print line, error. Okay, just for now, okay? But it's not a good practice. So we're going to say if some error condition, we're going to signal some error. Otherwise, it will be legal, in which case we're going to do from line 1 to line 2, right? You can see the structure here. So what we need to work out is this condition here. What should that condition be? Let's say, I'll give you the informal description. I want both parties to be single. How do I say that? There are at least 2 different ways to say it. I can get some input from you. What kind of expression do I need here? Do I need an integer expression, string expression, person expression, anonymous object? Well, what do I need? What do I need? Huh? Something like that. But let me just answer myself first. What I really need over here is a Boolean expression, right? Which you're trying to suggest. Why don't we try your suggestion first? We can go from there, right? Okay, for now, can you say that again, please? This does, okay, sure. That's what you meant, right? Okay, or?
So do you want the line which results in an error or not?
So say it again?
Do you want a line which results
No, yes, I want a line of expression there. I want some valid expression here, that's Boolean, which can be put in this if, so that at the runtime, if this expression here you're going to suggest evaluated true, that means we got some illegal marriage being proposed. That's what I want. So please. Okay, you're changing. So not this, just this spouse, right? You want something else. Okay, that's fine. So you want to do, again, this spouse. Not equal to null, I like it. And then, or, that's what you're suggesting. I'll give you one more moment to think, if that's really what you want to say, before I say something. You cannot change it. Are you sure? Huh? You mean just to remove this one, are you saying? Sure? Just for now. Okay, how about this? I'll cut this because this will be valuable too. Okay, final answer from you. Is this okay? Partially, I would say. This is saying this spouse, in this case Jim, the current object is single. That's good. But what if the one you want to marry to is not single? You're not covering that. Right? That's missing. Okay? So guys, this first thought over here is good, but only partially correct. It's not complete. Because this one here hasn't considered other than spouse. Right? But let me put back your initial thought over here. Is this okay? Okay, I like it. But why do you have to use, what's wrong with or over here? Yeah, I'm saying either he's single is okay or she's single, right? Right, exactly. Good, very good. You know, it's really good to, think about this kind of design decision for your code, right? Not correct, you gotta be both. Jim gotta be single, Elsa gotta be single, all right? And I want to suggest one more thing. And you guys took 1019 before, am I right? Okay. Do you know De Morgan? Heard about it? What's De Morgan? Not P and Q is equivalent to not P or Q, right? Something like that. Not P or not Q. Another one, not P or Q is equivalent to not P and not Q. I'm pretty sure I've seen that, right? De Morgan. Now, we can apply De Morgan here to make the expression slightly more compact. Which De Morgan should we use? Because we have n%, that's pretty much like a conjunction here, right? So by De Morgan, we can do the following. Equivalent to, right? That's a symbol you have seen before in the math class, right? I'll just say here. I can say it is not the case that this spouse, now, should I put not equal to null or equal null? Right? Not, right? And then, or other the spouse equals null. You can go this way here, or you can go this way here. Depends. If you just find this one here more straightforward to you, go for that, no problem. If you feel a little bit more confident with your logic ability, go for that, but just don't get it wrong. All right? Any question about this? That's also like a nice review about the logical operators, right? And of course, if I ask you a question about the other De Morgan rule, you should know how to apply them too, right? They're similar. Go ahead. I would say it's, if you ask me, logically they're equivalent. So it's like should you write 4 plus 3 or 3 plus 4? A little bit like that, right? They're equivalent. I would say it's a personal preference. If you ask me, I prefer the second one. To me, it reads like this. If the marriage is illegal, that means it's not the case. Either party is single, right? Now you can think about which one makes more sense to you. They are really the same. There's no really right or wrong. But I would say if you're reading other people's code, they might write either way. You want to convince yourself what they're doing is right. So in the test or in the exam, what can I do? For example, I might just change this to be or. I might change this to be and. Or I might just put an exclamation mark over here and ask you whether that's correct or not and fix it. Something like that. Right? You want to be very clear about what you're doing. All right, any questions, please, about this?
Sir?
Somewhere. Yes, please.
Can you explain why you use
Say it again?
Can you explain why you use and instead of or?
Sure, of course. You're saying the first version there, right? You're saying this one here?
Yes.
Okay, sure. So here we are putting this entire condition in the context of this if statement. We're saying that if this condition evaluates to true, we're going to signal an error about this proposed marriage. So what does it really mean for the marriage to be problematic potentially? If it is the case that the one party is not single, and also the other party is also not single.
But what if one party is single and the other party is not single?
No, sorry, let me say that again. I beg your pardon. If the this dot spouse is not equal to null, let me just write it down. Okay, this one over here really means, so this dot spouse not equal to null, that means it's already married, right? This over here, okay, I may have just made a mistake. Okay, we are good with this interpretation, right? Okay, maybe it's good to have some informal description here, just to help. We know that when we say this, that spouse not equal to null, that means the person is married. Okay, well, the other person is married. We want, if either one is married, then we should not allow. You're right, that should be or. Maybe that's what you're confused about. I do apologize, but it's a process. You have to really make sure you think through it yourself. Let me change it so there's no error on the notes. So the correct answer should be that we do this one over here, right? If either one is married, that would be considered as an error. But by applying De Morgan, we should really use this one instead. So we're going to say not the case. And then, oh, sorry, do the wrong place. And if it is not the case that both parties are actually single, then it should be considered as an error. Okay, that makes perfect sense. Yeah, okay, thank you so much for pointing that out. I appreciate it. Thank you. Yeah, hopefully you see what the error is, right? It's totally possible for any one of us. So just want to make sure every time you put down anything that's to do with logic, really think twice before you confirm. Yes. I can clarify. Just give me one moment. Yes, question. Yes, indeed, yes. That's another good suggestion from your classmate. If you really like, you can feel free to create another Boolean helper method, maybe call that legal marriage, and then just call this helper method here. Feel free to try that. Okay, let me just clarify again about why we're using or. When we have this expression here, this that spouse not equal to null. We're saying that this person here is married because their spouse is somebody else, right? So we're saying that either this person is married or the other person is married. Either one happening should make the proposed marriage illegal. So that's why we're using or, right? Because we're putting this here. Exercise for you. Very, very worth trying. Let's still talk about the married method, okay? Let me just forget about public just for now. Void, marry, person, other. Okay? Before we say that, The structure goes like this. If this condition occurs, we signal an error. Otherwise, we allow the marriage to occur. Let me flip the logic slightly. But I still want it to work. What I want to do is, if some condition happen over here, I'm going to say this the spouse equals other, and also other the spouse equals this. And I would say else error. Oh, you see what I'm doing here? This is valuable exercise for you to do. Let me just say what's the rationale, what's the structure for this exercise. Before, this condition here, if that's true, it tells you what the error is. This condition corresponds to some illegal marriage condition. But now the condition we want to put here corresponds to some legal marriage condition. Okay? That's what I want you to do. Okay? Exercise. You got to be very logical to do this exercise. Okay? Any question, please, before we move on? Okay, I really like you guys got engaged in the topic and also helped me correct my mistake. I really, really like it. Good. All right, let's move on. All right, that's the example that we just did. And then dot notation. Oh, a little bit more about marriage. Sorry, just a little bit more. Okay. Let's now answer some simple question. Okay. And we can also use this diagram here to help us. Let's say over here. I might need to draw new ones, but let's see. So the dot notation, we talk about using this in the method definition, but let's talk about using the dot notation, right? Let's make the following assumption. Again, we got name and spouse. Let's say we have a public method called just name, or get name. Let's say name, just to make it short. And also we got a public accessor method, spouse, which is going to return the spouse of the person. And let's say we have a person, Jim. Okay? Start with something simple one. What dot notation should you write to inquire about the name of Jim? Anybody? It's an easy one. Jim.name, right? It's not that complicated yet. Jim.name. What about Jim's spouse's name? Jim.spouse.name, right? If you think about it, it goes something like this. Jim dot spouse, which is going to give you this object here, and then dot name, which is going to give you Elsa, right? If you follow the diagram. Jim.spouse.name, right? But you got to be very careful. In this particular example, we know that Jim is not single, right? Meaning that Jim.spouse will really lead you to an object over here for which you can inquire about their name. But if you do this expression in general, it might run into null pointer exception if Jim.spouse is actually null. Agree? So you might have null pointer exception, right? That's something I just want to warn you about. So you got to be very careful. Can we try 3 more? Okay, I just want you to tell me how you will express that. Oh, Jim is not single. Easy. What should we do? A Boolean expression. Jim is not single. Jim.spouse, not now. That one's pretty good. We have done that. Okay. The marriage should be mutual. After we have done the marry method, we want to make sure not only that Jim's spouse is actually Elsa, but Elsa's spouse should also be Jim. Agree? How do we specify that in this case? So Jim.spouse equals Elsa is one side. But we want it to be mutual. We want to say somehow Elsa, the spouse, is also equal Jim. You might just need a longer expression here. I'll let everybody think before I can point to you. I'm pretty sure you know the answer, okay? All right, go ahead. What would be your suggestion?
Could you do something like gym.spouse equals gym.spouse.spouse?
Gym.spouse, okay, gym.spouse. Let's use a diagram. Gym.spouse equals gym.spouse.spouse. They are not equal. Agree? If I say here, let me write it down here. If you write, yeah, let me do it again. Okay, oh, sorry. I beg your pardon. Okay. What you said before, gym.spouse equals gym.spouse.spouse. We're talking about two different objects. Agree? Okay, I'm going to write this down. If I say gym.spouse equals gym.spouse.spouse, this is going to evaluate to false, given this particular setup, right? As I just illustrated. That's not the right answer, but getting close. Anybody?
Shouldn't gym.spouse equal gym.spouse.spouse.spouse?
Too complicated. Might work, but too complicated.
How about gym.spouse equals outside?
No outside here. We only got gym. Anybody? We're getting very close. Yeah, go ahead. Gym.spouse.spouse equals gym. Yeah, sounds good to me. Yeah, absolutely. If you go to the diagram here, gym.spouse should be equal gym. Mutual marriage. Think about this example here. All right? Final one. What does gym.spouse.spouse.name mean? Okay, if you guys are pointing somehow, that's on the right track. That means you're really thinking, right? Who is it Elsa or Jim? Yeah, right. You can see how fun it is, right, to use dot notation. It will be even more fun once we get to association. All right? Oh, sorry. I want to just illustrate to you. Gym.spouse.spouse.name. And in the test, I can go as many times as I like. I might give you a very long dot notation. Figure out. Okay? But if you got a diagram correctly drawn, nothing's hard. This is great. Right? All right. Before I leave for this example for good, any question? Go ahead. Good question. The question was, you just asked, why are we using equals as opposed to dot equals? Equals always compare references, like addresses between two reference types. Dot equals method, which we're going to cover maybe not next week, but the week after, before the reading week. Dot equals method is going to do something that depends on how you define your own class. But we don't really know how exactly the equals method has been defined for the person's class, so we better not use it just yet. But for now, I want you guys to know this. For comparing addresses between objects, always use equal sign. And when and how to use that equals method, bear with me for one more week, and then we'll get to it. You can, yes, that you're getting ahead. You can definitely redefine or override the equals method in any class you're defining, but that's something we'll get to about how you do it. Similar to the string method, string class, yes. In the string class, the equals method has been overridden or redefined to compare contents only. But if you want to do it for your own class, you have to be very careful about what you write, which can be tricky. Good? Yeah. All right, go ahead. Yes, the question was, if I only wrote gym.spouse, gym.spouse is actually going to give me some spouse, which is a person. So give me a person objects rather than a string objects. Right? Is that what you're asking? It will just give you an address for the person. But if I say gym.spouse.name, it's going to give me the name of that particular person objects. It's different. Okay? All right. Let me move on if no further question. Okay, and then we got helper methods that we cover. If you want to refer to the more practical demo, feel free to refer to the in-lab demo from last week. And then we got just one final topic, which is about static variables. I'm hoping to cover some today, at least some. All right, helper method is all good. All right. All right, nothing. Okay, static variable. Why don't we take just a 2 minutes break and then we'll come back. Please don't go too far, 2 minutes. The final topic to review for today will be static variables, okay? It's a very useful thing to have some global thing that's shared by all the objects of a particular kind. If you ask me, strictly speaking, static variable is not really OO because it's not really like an instance specific. It is something that doesn't depend on instances, but something global. But it's still very useful to have it, in your Java code. I believe, but I will check later. I believe in your lab number, maybe not lab number 1, but in lab number 2, you will have to have some simple application about static variable. But that's already covered in the slide, so you don't need to worry about it. It's a very standard way of applying things. What I want you to really focus on is to think about what's really the critical difference between non-static versus static variables in Java. That's important, okay? But let's see. I always like to motivate why do we really need static when we already got something that's already not static. Why do we need it? Let's say we want to solve a problem to assign IDs to bank account, right? Each bank account should have different IDs, right? Let's say for simplicity, they should have different ID. Let's say ID 1, 2, 3, 4, 5, all the way to 1,000, whatever, right? I want to give you some sketch of the solution here. Let's say this. We have a class called account, let's say for bank account. And we're saying that for every account, they should have some ID, right? Every account. If you imagine that we're drawing different boxes corresponding to different account objects, each one of them should have their own ID, instance-specific ID. And we also got owner, right? And we may just want to have an accessor just to return the ID of a particular account, which is okay. So now the principle is different account objects should have different IDs. Should have different IDs. So this is the principle I would like to stick to when we do the implementation. And what I'm proposing now on this page is one possible solution, but it may be a little bit ugly. Now we have the constructor for account, right? You can see account here, account, right? Now we talk about parameter design. Let's look at the parameter over here. I have some parameter ID, which is to say, every time you want to create an account object, you as the caller or you as the user of this constructor here, you must give me what that ID is. You must tell me. Otherwise, you cannot create it. For example, when I try to create the first account objects, second account objects, I must tell you explicitly 1 and 2. Right? Maybe I have some way to keep track of how many IDs I have used so far. So every time I'm going to tell you 1, 2, 3, 4, etc. Right? You can see pretty much the design. And then, of course, we can give the owner, and that can be Jin, can be Jeremy, right? And the implementation here, easy. Just this.id, ID, this.owner, owner. All right? Now, one way to verify, very easy, I can just say now account number 1, which is over here, account number 2, which is over here, their ID should be unique, different. So this implementation here works. Any question about this implementation here? It works. If you put that into JUnits, put it into a console tester, as long as every time when you're creating a new account object, you're just passing different integer ID, it's guaranteed the instance is going to have different IDs. Okay, so it works. But what's the drawback? In some way, I'm already telling you what the drawback is. Every time some user of your bank class, some user of your account class, they have to figure out what the IDs should be for the account. Shouldn't that be the job of the account class itself to say every time if I give you some account objects to be created, that account itself should already have a unique ID internally? That's really the design decision we want to go for. So what we really want to criticize about this design here, working but not really good. Too much burden on the user. Too much burden on the users of the account class. And if there are two users, let's say you and me, every time when we are trying to create different account objects, I don't really know what IDs you have already assigned to account objects. I might just duplicate it, right? It's not good. So what we really want is inside the account class, we want some internal global variable, like a global counter, to keep track of how many accounts objects have been used so far, and then every time just increment the counter somehow. So it's guaranteed to be unique every time. That's the solution that we want to work out. And what can we do? Static variables. All right? And before I give you the solution, which is very easy to see, but I would suggest we spend 10 minutes. Maybe that'll be it for today, hopefully. I want to give you some very quick demo on the paper only, right? I will make the source code available to you. Please play with it on the Eclipse if you can, to see the difference between static versus non-static variables. So you will really appreciate what the solution is like. Let's start with this. Okay, I will visualize in a moment. Only look at this part here, please. Only this part. Oh, sorry. Only this part here for now. So what we have is integer L, standing for local. Okay? Whenever you have a type over here that does not count with static, we call that non-static. This is a non-static variable, or attribute if you like. And this particular variable is going to be non-static. Each counter, well, we talk about counter class, right? Each counter has its own copy of this variable, L. That's really the essence of non-static variable. Every object of that particular type that you create has their own copy. Okay, separate copies. On the other hand, we got the second variables over here. You can see I'm using the word static. G standing for global. And for global variable, usually we give an initial value to start with. But typically, you don't really give the initial value for local non-static right here. It will work in Java, but you should really do this in the constructor instead, like what I'm doing here. Okay? And now this one here, let me just annotate it. So this one is a static variable. A single copy shared by all account objects. All account objects. Oops, sorry. Account objects. All right. And let's look at the methods over there. So in the constructor over here, we don't, okay, in the constructor, so do not, let me use a different one. So in the constructor, only initialize non-static attributes. Non-static attributes. You don't really initialize the global static variables in the constructor. You don't do that. because constructor is supposed to create individual instances. And you can have some accessor to get the local variable. You can also have some mutator to increment the local. And you have another method over here, which is going to increment the global variable, so we can see how things will work. Okay? Are we good with number one, the declaration of static versus non-static? And also how we can update each one of them using the method, right? Nothing really new. The only thing that might be a little bit new to you right now is by using the static. So what we have to know is in the tester, what's the consequence of declaring non-static versus static? That's something we're going to see. So once we see that, I will show you what the solution for that ID problem should look like. You will be able to understand. Okay? Let's now take a look at the tester here. All right? So what we have is we have two counter objects. Let's visualize right away. C1 pointing to a new counter object over here. Right? Counter objects. And now, how many attributes should I put over here? Just one. Because only one non-static attributes. You only visualize each individual object by enumerating their non-static attributes, not static. Static should not belong there diagrammatically. So I'm going to put L over here. And in the beginning, they will just be 0. Similarly, I got C2 pointing to a counter object over here. Local, L. Now you can see that what I meant by separate copies, right? So this 0 here has nothing to do with this 0 here. They are not linked in any way. And how do we visualize this static variable? It could be a little bit flexible. The way I would do it is like this. I'm going to set aside a space for static variable. Don't really get confused because I want to say this static variable belongs to the class, right? So I can still put counter over here. And instead, I'm going to say G here, global. But what I can do, I can just put a star. Let's say that's a convention. Star tells you that's a static variable, that's global. It's not shared among, well, it is shared among all the instances of counter, okay? So what I say star over here, I really meant static, global. What should be its initial value? Well, 0. Could be any value, but in this case, it will be 0. Every time you create a new object of type counter, you're only creating more boxes like this. But this is always one single copy, right? Only a single copy. A single copy shared by all counter instances or objects. All right, let's finish the tracing, okay? Let's now move on to, let's say, okay, this one here. I want to print out C1.getLocal. What should it be? 0. Agree? C2.getLocal. 0. Even though they're both 0, but they're referring to different copies over here, right? And then I want to know what's C1.g. Well, I can tell you that whenever you're referring to static variables, referring to static variable, the syntax will be, what you should do is to say the class name dot static variable name. So this is usually the syntax. Because the static variable really belongs to the class, but not a single object. But Java also allows you to really do something like this. I can say C1.global, C2.global. If you try this in Eclipse, it's going to put a yellow underline to say you should not try to refer to static variable using an instance. You should use the class name. And what should that be? Well, it's still referring to just this single copy, right? 0 and 0. Okay? And the proper way of referring to static variable is right here, counter.g. Right? You can see the counter here is really the class name. And the G here is really the static variable name. That's the correct syntax. Okay? Let's now do a little bit of updates. Let's watch out very careful here. C1.increment local, according to the definition, is going to update C1.L. Right? So C1.L increment is going to be 1. We're only updating this copy only. It doesn't affect the other copy. When I say C2.increment local here, right, I'm going to execute this method once more, but now that this will be C2. So now I'm updating this one to be 0 to 1. Now, let's try this. If I say C1.increment global, I'm basically saying update this only copy, and then it's going to be incremented to 1. At this point, if I say counter dot global, what should be its value? 1. If I say C1.global, also 1. If I say C2.global, it's also 1. Okay? Final one. What if I say over here, C2.increment global? Well, again, it's going to modify this single copy here from 1 to 2. So after this, you can definitely guess. After this, if I say counter.global, should be 2. C1.global should be 2. C2.global should also be 2. All right? Another way for you to update directly, you can also try counter.g is assigned to counter.g plus 1. That way, from 2 to 3. Okay? Like that. Give me 30 seconds. I can give you some homework, all right, for next Tuesday. Now that we talk about how the static variables behave, now I would like you to take a look at this solution. This is the solution to improve the first solution that we talked about, which is too error prone, which is manual, about managing the IDs. Take a look at this solution here. We'll start from here. Hopefully within 10 to 15 minutes on Tuesday, we can be done with all the OOP review. And then we'll start with exception. I've also made the slides available to you before Tuesday. Have a good weekend. I'll see you next week.